So here in this problem, we need to show that the product of x1 with x2 and x3, and this goes on all the way up to infinity, this value is -1 if the x is given by cosine of pi over 2 raised to the power of n plus iota times sine pi over 2 raised to the power of n. So let's begin. So what we'll do, we'll first consider a given expression. We'll consider n value to be equals to 1. So x1 is going to give us cosine of pi over 2 plus iota times sine of pi over 2. Next, we consider n value to be equals to 2. So this gives us x2, which will be equals to cosine of pi over 2 squared plus iota times sine of pi over 2 squared. Now let's multiply x1 with x2. So this is going to give us cosine of pi over 2 plus iota times sine of pi over 2. So this gets multiplied to the x2 value, which is cosine of pi over 2 squared, added to iota times sine of pi over 2 squared. We will multiply both of them. So cosine of pi over 2 multiplied to cosine of pi over 2 squared gives us cosine of pi over 2 times cosine of pi over 2 squared. Then we have iota times sine pi over 2 multiplied to iota times sine pi over 2. So we have sine pi over 2 times sine of pi over 2 squared. Now here iota times iota, this value is equals to iota squared, and we know that iota is -1. So this will be negative. So let's consider this to be the real part plus iota times. So here we'll find out the imaginary part. This is going to give us the value. So for iota, we have cosine of pi over 2 squared multiplied to sine of pi over 2 plus sine of pi over 2 squared multiplied to cosine of pi over 2. Right. This will now actually this is the expansion of cosine of pi over 2 plus pi over 2 squared plus iota times sine of, and this particular expression is the expansion of pi over 2 plus pi over 2 squared. So here what I wanted to show you here is if we take x1 and multiply it to x2, then we simply see that the arguments get added. So that means if we had x1 multiplied to x2 multiplied to x3, this is going to give us cosine of pi over 2 plus pi over 2 squared plus pi over 2 cubed plus iota times sine of pi over 2 plus pi over 2 squared plus pi over 2 cubed. Now in our problem, we have to take the product of x1, x2, x3, and this thing goes all the way up to infinity. So that means, and we can say that x1 multiplied to x2 multiplied to x3 multiplied to x4, x5, and this going all the way up to infinity. So this is going to give us cosine of pi over 2 plus pi over 2 squared plus pi over 2 cubed plus pi over 2 raised to the power of 4, and this goes all the way up to infinity, plus iota times sine of pi over 2 plus pi over 2 squared plus pi over 2 cubed plus, and this also goes all the way up to infinity. Now luckily this argument of both the cosine and the sine, these are in geometric progression. So that means pi over 2 pi added to pi over 2 squared plus pi over 2 cubed all the way up to infinity. This is an infinite geometric series. So since it's an infinite geometric series, so we can simply find out its summation. All we need is the first term. So our first term is pi over 2, and our common difference and a common ratio CR or simply R, this value will be equals to, we will take the second term, which is pi over 2 squared, and we'll divide with the first term pi over 2. So this is going to give us the value half, meaning that this particular sum, so this will be equals to A divided by 1 minus R, where R is the common ratio. So this is the sum of an infinite geometric series, which will be equals to A value, which is pi over 2 divided by 1 minus the common ratio half. So we have a value pi meaning our product x1 multiplied to x2 multiplied to x3, and this goes all the way up to infinity. So this is going to give us cosine of pi plus iota times sine of pi, because the sum of the geometric series is pi. The cosine of I, this value is -1, plus iota times sine pi, which is simply 0. So we are getting a value -1. Hence we have successfully shown that the product of x1 with x2, x3, and this goes all the way up to infinity, has a value of -1.